Well, hello there, and welcome to our realm of mathematical adventure. I, of course, am your host, Mr. Lupke, and it is an awesome honor to be able to welcome you, our mathematical legionnaires, as we discover the beauty that is mathematics. Today, we're going to take a look at two-step equations and how we simplify two-step equations in order to be able to solve for our missing variable. Well, let's take a look. Two-step equations have rules. In fact, the rules are almost exactly the same as our one-step equations that we've already talked about how to do. Well, let's review what those rules are, shall we? Rule number one, we have to isolate the variable. That means get the variable by itself. And when we get the variable by itself, we're able to do rule number two. We do that by doing rule number two, which is to isolate that variable, we use inverse operations. Those inverse operations allows us to get rid of what's not the variable on each side of the equation. Now, but when we do that, we have to remember rule number three, which is to always do the same operation to both sides of the equation. If we don't, it's no longer the same equation, and we've made some drastic mistakes. We're no longer in balance. And remember, in the realm of mathematical adventure, we love balance. Finally, and this is new when it comes to doing two-step equations, we want to make sure that to isolate the variable, we want to undo the constant first, the term that doesn't have the variable in it. And then we will undo the variable with the coefficient. But there's one exception to this rule, and we're going to share with you that exception and why it is so important to make sure we follow that exception. All right, let's take a look at some examples, shall we? All right, let's take a look at those examples for our two-step equations. Here's our first example, a basic two-step equation that you see all the time. Here it is. 6x plus 8 is going to equal 50. Standard way in which a two-step equation is going to be written. Now, let's follow our rules and let's make sure that we isolate our variable. Rule number one, right? Isolate the variable. How do we do that? By doing the rule number two, which is the inverse operations. But we have to make sure we do it to both sides to keep it in balance. But remember, the first thing we always want to make sure is rule number four. The fourth and final rule, which was to undo the constant first, not the term with the variable, to undo the term without the variable. Get rid of that first. And when we do that, we'll be able to solve for x. So this we need to undo. We need to get rid of the 8 over here. To do that, remember, we do follow rule number two. We do the inverse operation. Inverse operation of addition is subtraction. So we subtract 8 from both sides. Now, when we do that, we follow rule three, which is do the same thing to both. When we do that, those 8s are gone. They're out of here. And what's left is 6x. We just bring that 6x straight down. We bring down the equal sign because we haven't done anything. The equal sign just tells us the difference between one side and the other. Bring that down, and over here we have 50 minus 8. 50 minus 8 happens to be 42. Again, you could use your calculator if you need to. So now we have our new equation is 6x equals 42. Wait a second. That looks like a one-step equation that we've solved before. And you know what? You would be right. So you know what we're going to do? We're going to go back and do the rules all over again. Rule number one, isolate the variable. We do that by rule number two, opposite. We do the inverse operations, or the opposite. This is 6 times x, so we need to divide that side by x in order to get divide by 6 in order to get that x by itself. But we have to follow rule number three, which is when we divide the left side by 6, we need to divide the right side by 6. So those 6's are gone out of here. What's left is x equals 42 divided by 6, which is 7. And now we know what the value of x is. X is going to equal 7. Let's take a look at our second equation. Here, again, looks like a fraction, but remember, in the realm of mathematical adventure, a fraction is just another way to write division. So we know this is division, but we want to make sure, remember, we're going to follow rule number 4 first, and that is work on the constant that doesn't have the variable in it, the term without the variable. So we're going to move this over to the other side. All right, here we go. Let's do this. To do that, rule number 2, do the inverse operation. So plus 8, we subtract 8. Subtract 8 from the left side. But when we subtract 8 from the left side, we need to also follow rule 3. Subtract it from both sides. Do the same to both sides. I put my values there. I didn't do anything to this x divided by 6, so that's just going to come down. 8 plus 8, and I subtract 8 from that, it's gone. See you later. Now I'm left with, I bring that equal sign down, I'm left with 50 minus 8. 50 minus 8 is 42. And now I'm back to my one-step equation. One-step equation with division. We know what to do here. We do the opposite, or we do the inverse operation of division, which is multiplication. We multiply both that side by 6, and then we follow rule 3. We have to do it to both sides. So we multiply this side by 6. Whew, man, this is crazy. Let's take a look. That's 6 divided by 6. It's gone. See you later. Then what's left over is the x. Don't get rid of that x. We need it. Now we've got 42 times 6. Now some of you could probably do that in your head, but most of you are looking at, I need a calculator. Use that calculator. 42 times 6 happens to be 252. So I know that my final answer, that this x value is 252 in order to make this equation true. Let's take a look at a couple other examples, including the exception. All right, here's those second examples, and one of them, this one, that exception, looks pretty crazy. But let's talk about this one first. Again, don't let me fool you. The variable could be on either the left side or the right side. Just because it's on the right side here doesn't change what we do. Follow rule number 2. Okay? To isolate the variable, we do the opposite. We do the inverse operations, right? So we're going to do that inverse operations, but we do want to do that we want to follow rule number 4, which is do the constant first. Get rid of the constant first. So the inverse operations of plus 9 is subtract 9. So we're going to subtract 9 here from this side. And then we also want to make sure we follow rule number 3. Remember, do the same operation to both sides. So that means I'm going to subtract 9 on the left side. Okay, this plus 9, and then I subtract 9 from it. It's gone. See you later. What's left over on this side is a negative 4k. And then on the other side, 13 minus 9, we know what that is. 13 minus 9 is simply a positive 4. And now I have my new equation, that one-step equation. I got negative 4 times k. Well, to isolate that variable, I'm going to do the inverse operation of multiplication, division. So I divide both sides by negative 4. Now that I've divided by negative 4 on both sides, that was negative 4s on the left side, gone. Sayonara, adios. What's left over is the k. Don't get rid of that k. We've got 4 divided by negative 4. You know positive divided by negative is a negative, and then 4 divided by 4 is 1. So our answer is negative 1. Now comes time for that exception. Take a look at this. This is like a big, crazy numerator in that fraction. Well, in division, here's what we're doing. We're taking our variable x, we're adding 8 to it before we divide. So in order to do this, when one side is just one fraction by itself, and there are at least two terms in the numerator, well, we're not going to minus 8 first. We can't do this before we get rid of this denominator. When the fraction is the only thing, we have to get rid of the denominator first. So to do that, we're going to, you guessed it, the inverse operation of division is multiplication. So in our exception here for this, we're going to multiply the left side by 5. Following rule number 3, to stay in balance, we do the same operation to the other side. 50 times 5. This 5 and that 5, gone. Adios on the right side. What's left over is what's in the numerator. X plus 8 is the only thing left. Now we go to the right side. 50 times 5. 50 times 5 is 250. Okay? And now I have my one-step equation. Isolate the variable on the left side right here. I do that by doing the inverse operation of plus 8. That is, subtract 8. Now, keep it in balance. So I do it to the same to both sides. Once again, I bring the x down. And then 250 minus 8 is 242. And I have solved for the value of x. Guys, I hope this helped when it came to solving basic two-step equations. Okay? Make sure you keep practicing, and I'll see you next time.